Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 47's on the screen. Let's get started, please. Shouldn't take you long for some of those. Hopefully you remember. All right, here we go. So let's go with number one. Number one, just to recap. How do we graph f of x equals x squared? Well, here we go. We have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. You guys remember those? Yes? However, they want us to transform according to these. That's why I'm not graphing my parabola here. I'm just using those 5 points to save time. But I need to rewrite this. So some of you forgot. You put a 1 right here. And then we rewrite this one, and it becomes g of x equals the 1 with the 2 becomes a 1/2. Does everybody see that? The 1 with the 2 becomes 1/2. And what's left over? All of this. So that is f of x plus 3 minus 5. And since the parent function is a quadratic, I'm going to put a little 2 there. So we need to transform this. Where are we going to move all the 5 points? According to this, we're going to go down 5 and 3 to the left. But before we do that, we need to either stretch or compress. What does this do to the original one? Divided by 2, which means it compresses. If it was a whole number, it did what? Stretch. But in this case, it compresses. So instead of being negative 2, 4, it's going to be negative 2, 2. Instead of being negative 1, 1, it's going to be negative 1, 1/2. 0, 1/2, and 2. So these red ones, now I'm going to move which direction? 3 to the left and 5 down. 3 to the left, 5 down. So my new function is going to be compressed about right there. Is it coming back little by little? Yes? Yes, Mr. Q. All right, let's go with number 2. Can we have a negative exponent? No. If we put a 1 underneath, do the reciprocal, so it becomes 1 over a, and the exponent becomes a positive, Or, in other words, if we send this to the denominator, we change it to a positive. B, any number to the 0 exponent is 1. 1, any number. That's why I'm using those ridiculous numbers, 2,000 to the 0 exponent. Go to the C, distribute here and here, so we end up with 1 to the negative 5 over x to the negative 5. Can we have negative exponents? No, Mr. Q, so I send the 1 down here, change the 5 to a positive, and this one I send it up, so it's x to the positive 5, so this is x to the 5th over 1 to the 5th is 1, so this is x to the 5th. Number 3, this times this is 3 plus 5. So look up. This is, I've seen some of you are struggling with this, and I'm like, okay, maybe I'm not explaining it well. Let me go back to it again. Here it goes again. One more time, because we're about to get into some of that, those functions, and I want to make sure that you got this. Do you see that these two are the same? So that means they become 1. Okay, so what happens to the exponents when we multiply? You add, is that correct? So this is basically this. So if that's the answer, what was it before it became that? Well, 2 to the what? X times what? 2 to the negative 2. That's how we get that. And now by looking at this, can we have a negative exponent? No, so that goes down here to the positive. This one stays on the numerator. So 2 to the x over 2 squared is 4. All right. And last but not least, divide. Here we go. Let's do this one together. 3x plus 7 divided by x plus 2. I'm going to give you plenty of practice of this week so that next week when we get into the more complex functions, you know exactly what to do. So here we go. What number times x gives us 3x, everyone? 3. So 3 times x is 3x. 3 times 2 is positive 6. We're going to subtract. Distribute this here and here. And that leaves us with 7 minus 6 is 1 as the remainder. So what is my answer? My answer is 3. But do we have a remainder? Yes. What is the remainder? 1 over x plus 2, which is this. However, from now on, whenever you have something like this, I want you to move this constant, that's not part of the fraction, move it to the end. So we're going to put plus 3. And what's left here? 1 over x plus 2. This is what I want to see. Why is that? Because, like I said, we're going to be using that for transformations as part of the next section that we're going to get into. All right? So with that said, send me your warm-up. Let me send you a code really quick. All right, copy the agenda, please. Warm-up 47 done. We're in the middle of rational functions. And home plate for tonight, 8 rational functions, graphs only. All right? All right, copy this code to access the home plate. 3BW2Q. 3BW2Q. Write that down. 3BW2Q. 3BW2Q. Man, I can't believe we're almost in Thanksgiving. What? Ooh, I am, yeah. We usually go and help hand out food for the people, yeah. Yeah. And then from there we go and visit family. What am I gonna eat? Everything. Ooh. Both. All right, here we go. So your home plate. There it is on the screen, very similar to one that I left you guys already. However, today, guys, I'm gonna try to make it a little bit easier to graph than the other ones that we did. That took us a little bit longer, and because we're transferring now into transformations. All right, here we go. I can solve and graph rational functions. I can solve and graph rational functions. So when you hear the words rational functions, what is the one thing that you must see whenever you talk about rational functions? Tell your neighbor, what is the one thing that you should see in rational functions? Yeah, fractions, that is correct. Yeah, some of you said equations, yes, as well. So once again, equations with fractions, there they are. You already have those notes. I gave you guys steps to follow with asymptotes, input, output table, and graphing a function. Today we're going to be graphing without a table. What? All right. So once again, general rule, here it is. Our new rule is this one. Is that correct? And just a reminder, K goes up and down, H goes side to side, and A stretches or compresses. Yes? All right. Asymptotes. We talked about that it's an invisible line that the graph does not touch. We've been working with vertical. We've been working with horizontal, and we still haven't gotten to diagonal, slant, or oblique. We're getting there, though. All right? So, once again, from our form, K is our horizontal asymptote, and that looks like this, a dotted line going sideways. Our H is our vertical asymptote, and it's a dotted line going up and down. You guys remember that, yes? Yes, Mr. Q. And then from there we got into this by graphing our asymptotes, and then to this asymptotes as well. So, with that said, on your graph paper, write this down again. Graph the function f of x equals 1 over x. On your graph paper, at the top left. From this point forward, we're going to be on the graph paper. Okay. Here we go. Let's practice. First things first. Let's find our... Let's find our HA, or horizontal asymptote. Focus, please. HA, or horizontal asymptote. And then we also need our VA, our vertical asymptote. Now check this out. This, in order to know if it has it, those of you that don't see it, you want to write this underneath. That's going to guide us to look at this according to that. So first of all, our horizontal asymptote is the letter K. Is that correct? So question, does this have anything after the fraction? If it doesn't, that's why this is 0. So place your point on 0, and it's actually going to be our x-axis. Do a dotted line going sideways. Horizontal. Next, do we have anything next to the x, like this one? No, if there's nothing next to the x, that means that that is also 0. Place it on the point of origin, and that's going to be our y-axis. Are we there so far? All right. Next, I'm going to graph this parent function without a table. Look up. Look up, please. I'm going to graph this one as our parent function. I want you to label it parent. Why is it parent, Mr. Q? Because it starts with what? F of x. So, 1 over x. From now on, look up. When I ask you to graph f of x equals 1 over x, you're going to place the point on 1, 1, and then do the little curvy like that. There's our graph. -1, -1, and same thing, a little curve like so. And that is our f of x. Now, why is that so important, Mr. Q? Because now, from now on, we're going to use that to graph our other transformation functions. Any questions with this so far? No, Mr. Q. All right. So, with that said, let's go to the graph to the right of where you were at and write this one down. Example 2Q. G of x equals 1 over x minus 1 plus 2. Write that down to the right, graph to the right of that. And we're going to do this one together. And for tonight's home plate, you're not going to graph using tables. Tell your neighbor what I just said. Yeah, so it's going to go a lot faster. Okay. Everybody there? All right, step 1. Here we go. I want you to write step 1. Graph f of x equals 1 over x. And actually, let me change that to green. I'm going to change that to green. Sorry, guys. Just so that we know the step before we get to the other asymptotes. All right. So, and I love technology. Here we go. What is the first thing we do when you graph this? Well, we need the asymptotes. We need HA, HA, G of x, in this case is our f of x. F of x. All right, question. Is there anything after the fraction? No, so it's 0. So, place your point, dot, 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 dot. There it is. We also need a VA. Is there anything next to the x? No, so it's 0. 0, up and down, dot, 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 dot. Are we done graphing? No, those are just the asymptotes. How do we graph that? Tell your neighbor. Remind your neighbor. We just did one right now. How do we graph that? All right. Guide me on that one, Julian. What do I do? Yep, no. For this f of x. 1, 1. That is correct. A point on 1, 1. And your graph. And what else? And graph. Okay. However, this is our what? This is our f of x. And now we want to graph what, everyone? G of x. So before anything, look up. Now your brain should be ready since we did the warm-up together. Tell your neighbor where we're going to move this to according to that. Talk about it here. Where are we going to move that to? Where do we move that to? All right. Jacob, where are we going to move it to? 1 to the right and up 2. Hands if you got that. That is correct. 1 to the right and up 2. So that means I'm moving everything, look up, everything 1 to the right and up 2. Now, let me use my technology so you guys can see it. Look up. I'm going to move everything, look up, 1 to the right and 2 up. You guys see it? Do you see that it's transparent over here to the right and up? All right, so let me put it back. So, let's start with the points. Start with this one. Hold on. First of all, this point right here is 0, 0, right? So we're going 1 to the right and 2 up. 1, 2. So that means my asymptotes are right here and right here. Let's get your asymptote, please. Now check this out. On f of x, there's a point from the center, from the point of origin, 1 to the left and 1 down, and 1 to the right and 1 up. So now our center is here. 1 to the left, 1 down. From here, 1 to the right, 1 up. And this is our g of x. All right, let me send you a screen so you can send me your work. All right, from 1 to 5, I'll come to where are you with this so far? Where are we at? 1, 3, 6, 7, okay. Well, I said 1 through 5. All right. So as you're sending that in, here we go, the process again. Step 1, we graph f of x equals 1 over x, which means our HA is 0, our VA is 0. Here they are in red and blue. And then from there we just place 1 point down here on negative 1, 1, 1 to the right and up. There's our graph. And all we do is move it what for the transformation? 1 to the right and 2 up. Okay. Next, copy this one. Go, turn your paper over to the next graph. G of x equals 1 over x plus 2 minus 3. Yes. Are always going to be the same. All right, so here goes. Your colleague was elaborating. Look up, please. Your colleague. Look up, people. For f of x equals 1 over x. The point here, 1 to the right and 1 up from the point of origin, will always be there. The point 1 to the left and 1 down will always be there. Always. Never changes. Always. Now, why is that, Mr. Q? Well, let me elaborate. Look up. Linear function. Which point does it pass through? 1, 1. Quadratic function. Which point does it pass through? 1, 1. Cubic function. What point does it pass through? 1, 1. Therefore, rational function is always going to pass through what? 1, 1. That is correct. So when you reflect that, since it's a rational, that means the reflection is over here, and you do the same. All right, so with that said, is that good? Yeah? Thank you, Mr. Q. Yeah, you're welcome. Oh, that's not yours. All right, here we go. Tell your neighbor step 1 for this one before we do the transformation. Step 1. Yeah, graph what? F of x equals 1 over x. So, our HA f of x equals what, everyone? Are we getting confused? Our HA f of x is equal to 0. There's nothing here. So, 0. Our VA x equals, is there anything next to the x? No, it's also 0 going up and down. There it is. And now we just graph it. 1 to the right, 1 up. 1 to the left, 1 down. Focus, please, focus. So, we're done with the parent function. I'm going to switch out colors. Tell your neighbor where we're going to move that to according to this. Where we move that to according to that. Where to? Down 3 and 2 to the left. That is correct. Yeah, wait for the thumbs. All right, down 3, 2 to the left. So here we go. I'm going to move the point of origin 0, 0, 2 to the left, and 3 down. So we got 1, 2, 1, 2, 3. Focus, please. Which means my horizontal asymptote is right here, and my vertical asymptote is right here. You guys see it now? Yes? And to graph our g of x, where shall we place a point? Tell your neighbor, where do we place a point to graph it? All right, help us out, Miguel. Where do I place a point? -2, -3. We already placed the point of origin there, which is where both asymptotes. -2 and 2. -1, -2. Which means from here, 1 step up, 1 to the right. Yes. And where do we place the other one? -3, -4, which means from here, 1 to the left, 1 down. There it is. I'm going to send you the screen so you can send me your work. All right, let's continue. Focus, please. Let's go to the next graph. Copy this one. Example 2, mega Q. And for this one, yeah, let's do this one together. Here we go. Once again, step 1, we're going to graph what? F of x equals 1 over x. Stay focused, please. I'm going over this one over and over to make sure you got it. Here we go. So for this, we need our HA, which is f of x equals. Tell your neighbor what our f of x equals is for that one. 0. So we're at 0. Do a dotted line. going through 0 horizontally or sideways. We also need our VA, or vertical, up and down. X equals, is there anything next to the X? No, so it's 0 again, up and down, dotted line. All right, and now to graph this parent function, I'm labeling it again parent, from the point of origin, look up, those of you that are missing it, I go up 1, 1 to the right, plot my point, graph my function. From the point of origin again, 1 to the left, 1 down, plot my point, and graph my function. Now, what do you guys notice that the point of origin is where both asymptotes cross. Is that correct? So if I was to have the asymptotes over here, look up, that means where they both cross is here, so that means the new point would be right here and right there. Everybody following? All right, so with that said, let me erase that, and let's see where we're going to transform this to. Where are we going to send this to? Tell your neighbor, what steps? Where to where? First of all, this one is going what? Down. Mr. Q, this one is going to go 4 to the right? No, because now we have a 2 in front of it. So what do we do, everyone? Set it equal to 0 and solve. Plus 4 plus 4. 2x equals 4. Divide by 2, divide by 2. X equals 2. So that means it's going to go how many steps to the right, people? 2. 2 to the right and 3 down. All right, so here we go. I'm going to take this point of origin, 2 to the right and 3 down. 1, 2, 1, 2, 3. Is everybody following so far? So what does that mean, Mr. Q? That means that our new point of origin is here. That means that our red asymptote, or our horizontal, is going through it like this. And the blue one is going through that point like this. So, now that we have our asymptotes and where they intersect, tell your neighbor the 2 points that you need to graph our function. Then we're going to have Natalia enlighten us. Where do we graph those 2 points? Talk it over to your neighbor. Give them the 2 points. Where shall we graph those 2 points? All right. Give us our first point, Natalia Castro. Is she here? Yeah. Okay. Help her out, German. Give us a point. All right, here it goes again. For those of you that missed it, if you stepped outside when we were going over this, here it goes again. From here where both cross, you count 1 step up, 1 to the right, plot your point, and graph. That's our first point. Where's our second point? Again, go where both asymptotes cross, 1 to the left, 1 down, plot your point, and graph. And this is our g of x. Yes? Yes, we were at 0, right? Okay, so according to this, we're moving at what? 3 down, and then the x was what? 2 to the right. Because it's a positive 2, right? So that means I go 2 to the right, 3 down, and there's our cross. All right, let me send you the screen so you can send me your work, please. Just a quick reminder, some of you that get lost with some of this stuff, you shouldn't be leaving the classroom at the exact moment that I'm going over this. Please, pretty please. If you need to go to the restroom in period 2, go to the restroom in period 2. Go to the next one. Copy this one. Example number 3. Actually, no, too easy. Hold on. This one, example 3 super cube. Go to a new graph. Don't worry about domain and range. Right now we're just focusing on the graphing the function. No. That's the number that we substituted in there. A positive number. So watch. Yeah, let's see. If we were to substitute a negative, and there's already a negative in there, so negative times a negative is a positive, and what you're saying, yeah, we would go to the left. But since it's a positive x, when you substitute it, there's a negative already there. It's a negative 2, so it's moving to the right. All right, 3S cube. 3 super cube. It says graph the function. All right, here we go. I'm going to give you a head start. Step 1, you're going to graph f of x equals 1 over x. 1 over x. All right. HA f of x is what? Tell your neighbor, please. All right, Carlos. Zero. Okay, thank you. And it's going sideways. Now we need our, bless you, our VAX equals. Tell your neighbor what that is, please. All right, what is that, German? What is it? He said 0. That is correct because there's nothing next to the x here. Reminder with those cell phones, if I see you with your cell phone, I'm going to take it away. All right? What points do we need for our f of x? Tell your neighbor, what 2 points? They never change. 1, 1. Negative 1, negative 1. We're done with this step. Next, where do we need to move the whole thing? We need to move it what? 4 up. And how many to the right or left? We don't know until we solve for what? For x. So here we go. Minus 6 minus 6. 3x equals negative 6. Divide by 3. X equals what? Negative 2. If it's a negative, we're going in which direction? To the left. How many steps? 2. So I'm going to take this point where both intersect and move it 2 to the left, 4 up. 1, 2, 1, 2, 3, 4. So that means my new asymptotes are right here and here. Which means my 2 points go where? Tell your neighbor. Then German's going to enlighten us. Where do we place our new 2 points? Tell your neighbor, please. Two new points. All right, German. Give us 1 point. Negative 1 and 5. Hands, have you got that? That is correct, because if we go from here from the center, 1 up, 1 to the right, there it is. Tell your neighbor the second one. Then Gio is going to enlighten us. The second point. All right, Gio, go. Negative 3 and 3. Let's see. If we go here from the center, 1 to the left, 1 down, there it is. Hands, if you got that by yourself. From 1 to 5, how comfortable are you with this? 4, 5, 4, 5s, and a couple 2s. All right. All right. So send me that in, please. So I'm going to stop right there for tonight's home plate. The 8 problems are done like this. So make sure you put some work in. See you guys next time. Peace.